I'm pretty sure you have your own toys and play with them a lot, specifically dolls. But don't worry, it's completely okay if you don't play with them. But this time around, I'm going to make sure you play with one. Now let me introduce you to this doll. This is Anna. She's a matryoshka doll or a Russian nesting doll. Now Anna here is a special kind of doll. She's not like Barbie and Ken or like the other dolls that kids normally play with, but we can still play with her. Plus, you get a special treat in the end when you play with her. So, what are we waiting for? Let's go! So, how do we exactly play with Anna? It's quite simple, actually. We just open her up. Would you look at that? It's another Anna. Or is it? Well, they look exactly the same to me, so I think it's still her, but smaller. Now, I'm pretty sure you're also wondering what happens if we open smaller Anna, just like we did with a bigger Anna. Will there be another Anna inside? Let's see. There is another Anna. Now, I know what you're thinking. Just how many Annas are there? Or is there an infinite number of Annas that we just keep on opening them up, never stopping? Now, are you with me in finding out if there is ever an end to this? Let's find out. Ooh, empty. Well, as it turns out, that was our last Anna. But what do we have here? A chocolate? Well, I told you there was a special treat, didn't I? Go ask your dad for it for me, will ya? Now, what we just did while playing with Anna is an example application of what we call recursion. Recursion is a method where a function calls itself. Now, I'm going to show you how this works. Let's say this is our function. The next thing we're going to do is inside this function, we are going to write the very same function. What this does is calling the function itself. We can relate Anna here as the function. As you can see, every time we play with Anna, we open her. This is equivalent to when a program calls a function. To see how this works in recursion, we write this down. Let's name the function open. So when we see Anna, we open her. We see Anna again, we open her again. We see her again, we open her again. And again, and again, and again, and again, and again, and again, until the smallest Anna. But what happens if there is no such thing as the smallest Anna? And we're just going to keep on opening them forever. Just like Ant-Man going subatomic, then keeps on shrinking forever. Well, the good news is, if Ant-Man had a blue disk to stop shrinking, then in recursion, we have what we call the base case. The base case is the condition where the function doesn't call itself anymore, thus avoiding an infinite loop. When we played with Anna, the base case was the smallest Anna, where we found the chocolate. Let's see how this works in our program. Let's add see the chocolate, then under here, the program ends. This over here is the base case. And over here, where the function calls itself, is what we call the recursive case. Now let's take a closer look. We see Anna, we open. 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 We don't see Anna anymore, and instead, we see the chocolate. So this is where the program ends. To summarize, recursion is a method where the function calls itself. It has two parts, the base case and the recursive case. The recursive case is the condition where the function calls itself, and the base case is the condition where the recursive function ends.